Hello students, this is part 2 of adding and subtracting rational numbers, and in the last video we did decimals, and I intended to do everything in one video and that wasn't going to happen. So now we're going to look at fractions. Let's just start with something really basic. If I have a half plus a third. If you were doing this without a calculator, you have to remember that if you were adding a half plus a third, let me draw a picture. And there's a pie or something. Yeah, there's half the pie, and there's like a third. That's an awful picture, but I think you get the idea, kind of. That's a half, that's a third. If I want to express this as a nice single fraction of the whole pie, then I need to have a common denominator. I need essentially my slices to be the same size, because otherwise I don't have a succinct way to describe this. I'm just going to be saying, oh, I have a half plus a third. I have most of the pie. But how much is most? I don't know. I just have most of it. So what you're essentially doing when you're adding or subtracting fractions is you're taking your 1/3 and your 1/2 and you're splitting them into slices that we're pretending are the same size. Because those, like, look at this one and look at that one. Those aren't the same size, but pretend they're equal sizes. That's what we're doing. So looking at this picture, I can see that each of these slices that I made is a 1/6 of the pie. So we're going to be splitting the half and the third into sixths. So hopefully this will ring a bell to you when you learn this in 5th grade, 6th grade, and you're multiplying each fraction by 1, essentially 3/3 or 2/2, in order to get the denominators to be the same. So I want this to be something over 6 plus something over 6. And if I multiply 2 times 3, that gives me 6. 3 times 2 gives me 6. So the first fraction is 3/6, and you can see that here. This was my half right here. And you can see that that's 3/6. And then you can also see that the third is 2/6. So 3/6 plus 2/6. And then, again, as you can see in the picture, I have 1, 2, 3, 4, 5 sixths. So notice that once I got my denominators the same, you leave it alone. You don't add them. These do not become twelfths. I don't have 5/12ths. That would be half of this. That would be like that much right there, which is not what we have. I have 5/6. So once you get your denominators the same, you keep them. So denominator is the same, keep the denominator. And then I just added the numerators together. 3 plus 2 is 5. So let's do one without a picture, because it's not always convenient to draw a picture. Let's say I got 2/15 minus a third. Okay, so again, I need my pie slices to be the same size so I can have a succinct way of describing what I've got. Now, when I'm looking at my denominators, when I think of 2 and 3, I'm going to think of 6. 2 and 3 both go into 6. When I look at 15 and 3, I can turn 3 into 15. I don't actually have to do anything to this first fraction. I can just say multiply by 5/5, and that'll give me 15ths on the bottom. So I have 2/15, that didn't have to change, minus, and then 5/15. Now, I have 2/15 minus 5/15. I know my answer is going to be 15ths. Because when you have your denominators equal, go ahead and keep it. Don't add the denominators, don't subtract the denominators, don't do anything funny with the denominators, just leave it alone. Then I'm going to need to take 2 minus 5. So right there is going to be 2 minus 5. Now think about that. That's the same thing that we were just looking at in part 1 of the video. Positives are money you have, negatives are debt that you have, or that you owe. This doesn't change just because it's in the form of a fraction. It's still the same thing. I still have $2 in my pocket and I owe somebody $5, so I'm $3 in debt. And then you want to look at your answer and see if it's possible to simplify it. And in this case it is. So I can take, let me rewrite it just to be nice and clean. Both of these are divisible by 3. So 3 divided by 3 is 1, and it's still negative. It's still money we owe, that didn't change. And 15 divided by 3 is 5. So 2/15 minus 1/3 is negative 1/5. Let's try another one. Why don't you go ahead and try number 3, and maybe give number 4 a try, see if you can figure out what's different about it and what you might need to do about that difference. For number 3, remember to think of this as canceling a debt or just change it to a plus. And then I need a common denominator of 6 and 5, and when you think 6 and 5, hopefully you're thinking 30. So you can multiply by 5 and multiply these by 6. So you'll have negative 10/30 plus 24/30. And then I hope you're remembering that debt and money in your pocket sort of thing. Because when you keep your denominator of 30, because you do have a common denominator, then up top you have negative 10 plus 24. And if you remember your money analogy, then you know you have a $10 debt, $24 in your pocket, which leaves you with positive $14. And then you can simplify that fraction. 14 and 30 are both divisible by 2. So again, I'm just rewriting it to keep things neat. I can divide both of these by 2, which gives me positive 7/15. Okay, so now for number 4. Boy, that's a crooked line. That's okay. Number 4. I have an improper fraction, which just means the numerator is bigger than the denominator. There is nothing wrong with those. In fact, once you get past elementary school or so, they're a whole lot easier to work with than this, which is a mixed number, which means you've got an integer portion or a whole number portion and a fraction. So I would suggest, if you see a mixed number, turn it back into a fraction. And again, think about what that mixed number really means. It means I have 1 whole pie, and then I have 1/3 of a pie. So think of this whole pie. Think of this whole pie as 3/3. So if I slice this pie into the same number of pieces as this one originally had, it's going to have 3 pieces. So I really have 1, 2, 3, 4 thirds. So essentially what you do is take the number of pieces times the number of whole pies, and then add on the number of pieces in the numerator. So 6/5 minus, and this is 4/3. So again, multiply the number of whole pies times the number of pieces. So whole pies times pieces in a whole pie. So that's the 1 times 3. Then add the number of extra pieces, which is the numerator. Okay, so 4/3. Then you just need a common denominator like before. And for 5 and 3, I'm going to think 15. Now notice one thing that people are unsure about, especially if they haven't done this in a while, is that the numerator and denominator of one fraction have to be multiplied by the same thing. Because you're really multiplying by 1, which doesn't change the amount of pie you have, it just cuts it up into more pieces. But the 2 fractions can be multiplied by different numbers. So here I'm doing by 3s, here I'm doing by 5s, and that's fine. So that gives me 18/15 minus 20/15. Remember, once you have the same denominator, just keep it. And then on top you have 18 minus 20. So $18 in your pocket, but you owe $20. So you're $2 in the hole, so it's negative 2/15. Nothing with adding or subtracting, but I want to show you how to convert from an improper fraction to a mixed number in case you wanted to do that. You may not always have to, but that's a thing that's good to know how to do in case you want to. So let's say I have 25/15, and I want to write it as a mixed number. So think to yourself that an entire pie has 15 pieces. So how many whole pies can you get if you've got 25 pieces. I can for sure get 1 whole pie. And then, so this is, we got 15 there for sure, but I can't get another 15 because I'd be 30. I have, in fact, 10 left. So I have 1 whole pie, see, 1 whole pie with 15 pieces. And then I have 10 pieces left over from a second pie. So I have 1 and 10/15ths. And I could simplify this. It's a good idea to simplify when you can, just because if you have smaller numbers to work with, that can make your calculations a lot easier to do. So I have 1 and 2/3. So 25/15ths is the same as 1 and 2/3. Or let's try, one other one. How about 67/12ths? Okay, so think, if I have 67 pieces, 1 whole pie has 12, how many whole pies can I get? So how many times does 12 go into 67? Well, if you know your 12s, which if you're going to memorize anything, I do recommend working on your times tables. It's just a really big time saver if you know that 5 times 12 is 60. So there are all sorts of games you can get on your phone to help you practice that if that's what you're into, but I would suggest doing it. In any case, so 60 plus 7. So I can get 60 pieces into whole pies. So I have 5 whole pies. That's the 60 pieces. And then I have these 7 pieces left over that I can't make an entire pie. It's just 7/12ths of a pie. So 67/12ths is 5 and 7/12ths. And if you were to go, where did I put that? Oh, right here. If you were to go and do that backwards, 5 times 12. So you take your whole pies times the number of pieces in a pie. So whole pies times the number of pieces. 5 times 12 gives you that 60. And then you add the numerator. So you add the 7. So that's how you get 67/12ths, which is what we started with. So I just wanted to show you that real quick. It shouldn't come up for you too often. I see it maybe a little bit when I took the TSI as an experiment, although they have changed the TSI since then. But it's good to have in your back pocket in case you need it. But either way, please let me know what questions you have. You can never ask too many questions. And thank you for watching.